Hello guys, hope you're doing well. Today we're gonna talk about differentiating only the vanishing factor. Suppose f of x is equal u of x times v of x, and us on that v of a is equal 0. Then by the product rule we have f prime of x is equal u prime of x times v of x plus v prime of x times u of x. So at x equals a, if we just plug in the value of x means a, we have f prime of a is equal u prime of a times v of a plus v prime of a times u of a. Since v of a is equal 0, the first term disappears, means f prime of a is equal v prime of a times u of a. So we don't need the full derivative of the whole product. Okay? So look at the function first before differentiating everything. If one part becomes 0 at the required point, the part is the only part we really need to differentiate. For the rest, we just plug in the value of x. Let's solve a few examples of this. For example, find f prime of 2 if f of x is equal x squared plus 1 times x minus 2. At x is 2, x minus 2 becomes 0, so that part is the only part we really need to differentiate. And then for the rest, we just plug in the value of x. So f prime of 2 is equal 2 squared plus 1, 2 squared plus 1 times the derivative of x minus 2 is 1. So we have 2 squared plus 1 is 5. That's it. It's very simple. Number 2, find f prime of 1 if f of x is equal x squared plus 3 times sine of x times x minus 1. At x is 1, x minus 1 becomes 0, so that part is the only part we really need to differentiate, and then for the rest we just plug in the value of x. So f prime of 1 is equal 1 squared plus 3 is 4, sine of 1 is sine of 1 times the derivative of x minus 1 is 1. So we have f prime of 1 is equal 4 sine of 1. Or find f prime of pi if f of x is equal x squared plus 3x times sine of x. We know that sine of pi is equal 0. So at x is pi, sine of pi becomes 0. So that part is the only part we really need to differentiate. And then for the rest, we just plug in the value of x. So f prime of pi is equal pi squared plus 3 pi times the derivative of sine of x if x is pi. The derivative of sine of x is cosine of x, so cosine of pi is equal -1. Okay, so we have f prime of pi is equal negative pi squared plus 3 pi. That's it. Or find f prime of 4 if f of x is equal x minus 4 times the square root of 2x plus 1 over x squared plus 3. At x is 4, x minus 4 becomes 0, so that part is the only part we really need to differentiate. So the derivative of x minus 4 is 1. And then for the rest, we just plug in the value of x. So we have f prime of 4 is equal, the derivative of x minus 1 is 1 times we plug in the value of x. The value of x is 4, so we have the square root of 2 times 4 is 8 plus 1 is 9. The square root of 9 is 3 over 4 squared plus 3 is 19. So f prime of 4 is 3 over 19. Or Find f prime of 0 if f of x is equal e to the x times cosine of x squared plus pi times sine of x. We know that sine of 0 is equal 0. So that part is the only part we really need to differentiate. So we know that the derivative of sine of x is cosine of x. So f prime of 0 is equal, we just plug in the value of x for the rest. So e to the 0 times cosine of 0 plus pi is pi times the derivative of sine of x when x is 0. The derivative of sine of x is cosine of x. So cosine of 0 is 1. So e to the 0 is 1, cosine of pi is negative 1, and cosine of 0 is 1. So f prime of 0 is negative 1. Or find f prime of 2 if f of x is equal x squared minus 4 cubed times ln of x plus 1. If x is equal 2, so x squared minus 4 becomes 0. So that part is only part we really need to differentiate, and we just plug in the value of x for the rest. So we have f prime of 2 is equal the derivative of x squared minus 4 cubed times ln of 2 plus 1. Okay, so the derivative of x squared minus 4 cubed is equal f prime of 2 is equal 3 times x squared minus 4 squared times the derivative of x squared minus 4 is 2x times ln of 3. So if we plug in the value of x means 2, here is 0, so f prime of 2 is equal 0. So if the vanishing factor has an exponent greater than 1, the derivative at that point will almost always be 0.